Show that x squared minus 3x plus 1 is a factor of 2x cubed minus 11x squared plus 17x minus 5, and find the other factor. So we're going to use algebraic long division. We're going to set up our bus stop. We're going to put 2x cubed minus 11x squared plus 17x minus 5 under the bus stop, and x squared minus 3x plus 1 in front of the bus stop. We then take the highest power of x under the bus stop, which is 2x cubed, and divide it by the highest power of x outside the bus stop, which is x squared. 2x cubed divided by x squared is 2x. So 2x goes on top of the bus stop. That's the first part of our other factor. We then multiply the 2x by what's in front of the bus stop, x squared minus 3x plus 1. 2x by x squared is 2x cubed. 2x by minus 3x is minus 6x. 2x by 1 is 2x. We write this down here. Then we change the signs. So I've written in red what the new sign is. So this becomes a minus, this becomes a plus, this becomes a minus. 2x cubed minus 2x cubed cancels. Minus 11x squared plus 6x squared gives us minus 5x squared. 17x minus 2x is 15x. And then we bring down the minus 5. Then we repeat the process again. We take the highest power of x under the bus stop, which is minus 5x squared, and divide it by the x squared, and we end up getting minus 5. We then write the minus 5 on top of the bus stop, that's the other part of our factor, and multiply it by what's in front of the bus stop. So minus 5 by x squared is minus 5x squared. Minus 5 by minus 3x is plus 15x. Minus 5 by 1 is minus 5. I'll write this down here, and again we change the signs. So I've written in red what the new sign is. So this becomes a plus, this becomes a minus, this becomes a plus. They all cancel, leaving us with a remainder of 0. Because the remainder is 0, x squared minus 3x plus 1 is a factor of 2x cubed minus 11x squared plus 17x minus 5, and the other factor is 2x minus 5. If we are told that one polynomial is a factor of another and are asked to work out or relate unknown coefficients, we can divide in and insist that the remainder is 0. We do this by saying that the two lines above the remainder must be identically equal. So we've already worked with identically equal polygons in the last video, so we should be familiar with them. Thus, we put like to like and deal with the equations we get. So if x squared minus p is a factor of ax cubed plus 5x squared plus bx plus c, show that AC is equal to 5b. So we set up our bus stop, and we're going to put ax cubed plus 5x squared plus bx plus c under the bus stop. So we have ax cubed plus 5x squared plus bx plus c. We then put our factor in front of the bus stop, which is x squared minus p. Then we take the highest power of x inside the bus stop, which is ax cubed, and divide it by the highest power of x outside the bus stop, which is x squared. And ax cubed divided by x squared is ax. We then write ax on top of the bus stop, that's the first part of our factor, and multiply it by what's in front of the bus stop, which is x squared minus p. So ax by x squared is ax cubed, and ax by minus p is minus apx. So we're going to write this underneath here. Now it's important to notice that we've left a gap, because we want to group together our x cubes and our x's. And since when we worked this out we didn't actually come up with an x squared, we just leave a gap underneath the 5x squared. So the ax cubed goes underneath the ax cubed, and the minus apx goes underneath the plus bx. So we keep the x's together and the x cubes together, and we leave a space for the x squareds. Okay, so again we change our signs. So these are going to cancel out. We're going to bring down the 5x squared, and plus bx plus apx, what we're going to do is factorize and take out the highest common factor, which is x. We're going to say x into bx leaves us with b, so b goes in the front of our brackets. And x into plus apx leaves us with plus ap. So plus ap goes in the back of our bracket. And then we bring down the plus c. So then we repeat the process. We take the highest power of x inside the bus stop, which is 5x squared, divide it by x squared, and that leaves us with 5. So 5 goes on top of the bus stop, so that's the other part of our factor. We then multiply 5 by x squared minus p. 5 by x squared is 5x squared. 5 by minus p is minus 5p. Then we're going to take this and we're going to write it under here. And again, we're going to group the like terms together. So the 5x squared goes underneath the 5x squared. And the minus 5p goes underneath the c, since neither of those have x's. So we don't actually have an x term. So we have a space. Now, since we don't have an x term, what we could actually write in there is 0x, just for the moment. Now, there's a few ways that you can look at this. You could say, well, we're going to change its signs like we always do, and the 5x squared and the minus 5x squared will cancel, and then this would become a plus. So we'd have c plus 5p is equal to 0, because we have to let our remainder be 0, because we're saying that this is a factor of this. So we could say c plus 5p is equal to 0, and then c would end up being equal to minus 5p, because we bring the 5p over the other side. Or what we could do is we could work with the fact that we are letting them be identically equal and put like to like. So when we were working with identically equal polynomials in the last video, what we did was we said anything that was stuck on in front of the x values, we automatically let them equal each other. So since these two equations are identically equal, we have an x squared, an x, and a constant at the end. So we can let whatever is in front of the x be equal to each other. So b plus ap is going to be equal to 0. So b plus ap is going to be equal to 0. Because remember, we're not interested in the x's anymore. We've matched these up now. So all we want to do is work with the a, the c, and the b, because ultimately we're trying to show that AC is equal to 5b. So we're going to let b plus AP equal to 0, b plus AP equal to 0, because they're both stuck on in front of the x. And then we're going to let c equal minus 5p. So c equals minus 5p. So you can look at it whichever way you want. You can say one way of doing it is that we've changed the signs here, which is what we traditionally do when we're doing long division. And we're going to say c plus 5p is equal to 0, which it is. Or you could take the original sign, which was a minus, and just let the c equal the minus 5p, because they are the constants at the end. So c equals minus 5p. It gives you the same thing either way. So we've set up two equations. The first one is b plus ap is equal to 0. And the second one is c equals minus 5p. So we've got two equations. Now, in the question, we were asked to show that AC is equal to 5b. So there's no p mentioned up here. So we want to eliminate p from these equations. So what we're going to do is take one of the equations and rearrange it so that the p is on its own. It doesn't matter which one we take. So I'm going to go with c equals minus 5p. And I'm going to divide across by minus 5. So that I get p is equal to minus c over 5. So now I have the p on its own. I have the p as the subject of the formula. And then I'm going to substitute that into the other equation. So I'm going to swap that p for minus c over 5. So I've put that p in here. So now I have b plus a multiplied by minus c over 5 is equal to 0. I have no p's anymore, which is what I wanted. Now to get rid of the fraction part, we're going to multiply by the denominator, which is a 5. So b times 5 is 5b. And a times minus c over 5 times 5, what will happen is the denominator will cancel. So we'll get a times a minus c, which is minus ac, equals 0. And then all we have to do is bring the minus ac over the equal sign to get plus ac. So we have 5b is equal to ac, and that's what we were asked to show. If x minus 1 squared is a factor of ax cubed plus bx squared plus 1, find the value of a and find the value of b. So trying to figure out what this a and b values are. So we're going to start by multiplying out x minus 1 squared. And x minus 1 squared is going to give us x squared minus 2x plus 1. So then we're going to set up our bus stop. We're going to put ax cubed plus bx squared plus 1 under the bus stop. Notice that I'm leaving a space here because we don't have an x term. We have an x cubed, an x squared, and a constant, but no x, so we're leaving a space. And then we're going to put x squared minus 2x plus 1 in front of the bus stop. We're going to take the highest power of x under the bus stop, which is ax cubed, divided by the highest power of x outside the bus stop, which is x squared, and we end up getting ax. So we put ax on top of the bus stop. That's the first part of our factor. And then we're going to multiply that by what's in front of the bus stop. So we get ax by x squared is ax cubed, ax by minus 2x is minus 2ax squared, ax by 1 is plus ax. So we're going to write this underneath the bus stop, making sure that we group our like terms together. So the x cubed goes under the x cubed, the x squared under the x squared, the x goes under the space because we don't have an x value above. Then we change our signs. What I've written in red is the new sign. These cancel. Bx squared plus 2ax squared. We're going to factorize. We're going to take out the x squared as the highest common factor. X squared into bx squared leaves us with b, so b goes in the front of our bracket. And x squared into plus 2ax squared leaves us with plus 2a. We bring down the minus ax, and we bring down the plus 1. So we have b plus 2a times x squared minus ax plus 1. We then repeat the process, so the highest power of x in front of the bus stop is x squared, the highest power of x outside the bus stop is x squared, and x squared divided by x squared is 1. So we're going to write 1 on top there, and 1 multiplied by x squared minus 2x plus 1 is x squared minus 2x plus 1, so we write that down here. So another way of looking at it is that at the second stage of division, so at this point here, we multiply by 1 because the two lines above the remainder have to be identical. They have to be identically equal. So that's really why we have the 1 here, because these have to match up. They have to be identically equal so that we can put like to like. So again, there's two ways of looking at the next step. Either way, we're going to let it all equal to 0 because we know that this is a factor of this, so we have to have a remainder of 0. So one way of looking at it is we could say, right, well, we're going to change the signs. So the x squared becomes minus x squared, the minus 2x becomes plus 2x, and the plus 1 becomes minus 1. So I've written in red the new signs. So we'd forget about the x squareds, remember that this is a minus, and we would say, well, b plus 2a minus 1 is all equal to 0. So b plus 2a minus 1 is equal to 0. And then we could just bring the minus 1 over the other side. Or you could say b plus 2a is equal to 1. Because remember, that was originally 1x squared. So we could say b plus 2a is equal to 1. It doesn't matter which way you want to set it up. So likewise, we could say minus a, so we're forgetting about the x's because we've matched up the x's, minus a plus 2 is equal to 0. So minus a plus 2 is equal to 0. You could bring the 2 over the other side and it would be minus a is equal to minus 2, and then a is equal to 2. Or putting like to like and taking the original sign, we could say minus a is equal to minus 2. So minus a is equal to minus 2. So a is equal to 2. And then the 1s will just cancel out either way because we don't have any a's or b's stuck onto the 1s, so we're not interested in them. So either way, you're going to set up your equations. You're going to have b plus 2a is equal to 1 and a is equal to 2. So what we're going to do is substitute a equals to 2 in place of the a, and 2 by a is 4. So we get b plus 4 is equal to 1. And then we're going to bring the 4 over the equal sign, it becomes minus 4. And minus 4 plus 1 is minus 3. So b is equal to minus 3. So we're asked to find the value of a and b. So a is equal to 2 and b is equal to minus 3.